Welcome to the world of IP addressing fundamentals. In this presentation, we will demystify Internet Protocol version 4 addressing, covering the basic structure of an IP address, diving into address classes, and clarifying the distinction between private and public IP addresses. Let us get started. Let us understand what exactly an IP address is. An Internet Protocol address is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. Think of it as a postal address for your computer on the Internet. It serves two primary functions. 1. Network identification. This identifies the network to which the device is connected, and 2. Host identification. This identifies a specific device on that network. Typical IP address looks like this: 192.168.1. Each of these numbers is called an octet. An IP address is actually a 32-bit number, but for human readability, it is written in the decimal format. In binary, the same IP address can be written as 11000000, 10101000, 00000001, and 00000001. Now let's take a closer look at the structure of an IP version 4 address. As we have already seen, an IP version 4 address is a 32-bit address, which is equivalent to 4 bytes. Each byte is called an octet. So an IP version 4 address is divided into 4 octets. These octets are represented in dotted decimal notation, meaning each octet is separated by a dot. Each octet can have a value ranging from 0 to 255. The total number of possible IP version 4 addresses is 2 to the power 32, which equals 4,294,967,296. Out of these, some addresses are reserved for special purposes. Historically, IP version 4 addresses were classified into different classes. This was a traditional way to categorize IP addresses based on their first octet. The address classes are Class A, Class B, Class C, Class D, and Class E. Class A addresses have a first octet range from 1 to 127. The first bit in Class A address is always 0. In Class A addressing, the network portion is 1 octet and the host portion is 3 octets. These are used for large networks. Class B addresses have a first octet range from 128 to 191. The first 2 bits in Class B address are 10. In Class B addressing, the network portion is 2 octets and the host portion is also 2 octets. These are used for medium-sized networks. Class C addresses have a first octet range from 192 to 223. The first 3 bits in Class C address are 110. In Class C addressing, the network portion is 3 octets and the host portion is just 1 octet. These are used for small networks. Class D addresses have a first octet range from 224 to 239. The first 4 bits in Class D address are 1110. These are used for multicast addressing. Class E addresses have a first octet range from 240 to 255. The first 4 bits in Class E address are 1111. These are reserved for experimental purposes. A quick note: the letters N and H shown here represent the network and host portions of the address, respectively. Modern networks typically use CIDR, which is classless inter-domain routing, instead of this class-based addressing. Class A addresses were designed for very large networks. The key characteristics are: the first bit is always 0. The range of these addresses is from 1.0.0.0 to 127.255, 255. The first octet identifies the network, and the last 3 octets identify the host. Class A supports 126 networks, that is 2 to the power 7 minus 2, and each network can have 16,777,214 hosts, that is 2 to the power 24 minus 2. Here we can see the network and host portions of a Class A address. The first octet is the network and the last 3 octets are the host. Some examples of Class A networks are 10.0.0.0/8. This is a private network. 17.0.0.0/8. This belongs to Apple Incorporated, and 9.0.0.0/8 belongs to IBM. There are some special cases to keep in mind. 127.0.0.0/8 is reserved for loopback addresses, and the network 0.0.0.0 is also reserved. Class B addresses are designed for medium-sized networks. The key characteristics are the first 2 bits are always 10. The range of these addresses is from 128.0.0.0 to 191.255.255.255. The first 2 octets identify the network, and the last 2 octets identify the host. Class B supports 16,384 networks, that is 2 to the power 14, and each network can have 65,534 hosts, that is 2 to the power 16 minus 2. Here we can see the network and host portions of a Class B address. The first 2 octets are the network and the last 2 octets are the host. Some examples of Class B networks are 172.16.0.0/16, which is a private network range. 172.17.0.0/16 is the default network used by Docker, and 191.255.0.0/16 is the end of the Class B range. The private address range for Class B is 172.16.0.0 to 172.31.255.255. These are commonly used in corporate networks and are not routable on the public internet. Class C addresses are designed for small networks with a limited number of hosts. The key characteristics are the first 3 bits are always 110. The range of these addresses is from 192.0.0.0 to 223.255.255.255. The first 3 octets identify the network, and the last octet identifies the host. Class C supports 2,097,152 networks, that is 2 to the power 21, and each network can have 254 hosts, that is 2 to the power 8 minus 2. Here we can see the network and host portions of a Class C address. The first 3 octets are the network and the last octet is the host. Some examples of Class C networks are 192.168.0.0/24. This is a common home network. 192.168.0/24 is the default network for many routers, and 203.0.113.0/24 is an example used for documentation purposes. The private address range for Class C is 192.168.0.0 to 192.168.255.255. This is the most common range in home and small office networks. These are ideal for networks with fewer than 254 devices. Now let's discuss Class D and Class E addresses. Class D addresses are reserved for multicast groups. The range for Class D is 224.0.0.0 to 239.255.255.255. The first 4 bits are always 1110. These are not assigned to individual hosts, but are used for one-to-many communication. Class D addresses allow a single sender to transmit to multiple receivers simultaneously. There is no network or host division in these addresses. Some common multicast examples are 224.0.0.1, which is for all hosts on a subnet, 224.0.0.2, which is for all routers on a subnet, and 239.0.0.0/8, which is for local network multicast. Class E addresses are reserved for experimental use and research purposes. The range for Class E is 240.0.0.0 to 255.255.255.255. The first 4 bits are always 1111. These are not allocated for public use on the Internet and are reserved for future use and testing. Class E addresses are not supported by most network equipment. The special address 255.255.255.255 is a broadcast address. Most Class E addresses are unusable in practice. Please note that most routers and hosts are configured to discard traffic to or from Class E addresses by default. Now let's differentiate between private and public IP addresses. Private IP addresses are used within local networks. They are not routable on the public Internet. These are used within homes, businesses, and organizations. These addresses can be reused across different private networks. Private IP addresses require network address translation, which is NAT, to access the Internet. They provide security by hiding the internal network structure and are free to use, meaning no registration is required. The private address ranges as defined by RFC 1918 are for Class A 10.0.0.0 to 10.255, 255, which is also represented as 10.0.0.0/8. For Class B, it is 172.16.0.0 to 172.31.255, which can be represented as 172.16.0.0/12. For Class C, the range is 192.168.0.0 to 192.168.255, also represented as 192.168.0.0/16. Public IP addresses are globally unique and used for direct communication over the Internet. These are assigned by Internet Service Providers or ISPs. They must be globally unique across the entire Internet and are directly accessible from anywhere on the Internet. These are used by servers, routers, and Internet-facing devices. Public IP addresses are typically leased or purchased from ISPs or registrars. Any valid IP version 4 address that is not in the private ranges is considered a public IP address. Examples include 8.8.8.8, which is Google DNS, and 104.26.229, which is Cloudflare. Public addresses are managed by regional Internet registries, such as ARIN, RIPE, and APNIC. In summary, let us go over the key takeaways from this presentation about IP version 4 addressing. Firstly, the structure of IP version 4 addresses. These are 32-bit addresses divided into 4 octets. These use dotted decimal notation, such as 192.168.1. Each octet ranges from 0 to 255, giving a total of approximately 4.3 billion possible addresses. Secondly, address classes. Class A addresses are used for large networks, such as 10.0.0.0/8. Class B addresses are for medium networks, such as 172.16.0.0/12. Class C addresses are used for small networks, such as 192.168.0/16, and classes D and E are for special purposes. Thirdly, private versus public addresses. Private addresses are used within local networks and are not routable on the Internet. Public addresses are globally unique addresses and are directly accessible from the Internet. And lastly, modern addressing. CIDR, which is classless inter-domain routing, replaces the traditional class system. NAT, or network address translation, helps conserve public IP addresses. IP version 6 addresses address IP version 4 address exhaustion, and subnetting optimizes network organization. That is all for this presentation. Our next topic will be subnetting and CIDR notation. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.